my talk is called Update from the Phoenix team. I am Steffen. You may know me as Steffen DE on GitHub. And I'm a member of the Phoenix and primarily LiveView team. Today, I want to talk about what happened in the last 2 years since LiveView 1.0. First, a small timeline of the releases that we did. So we had the first release candidate for 1.0 almost 2 years ago. And then it took us quite a while, like half a year, until the final 1.0. We took our time. I've been thinking we maybe should have done a 0.21 instead, because people seem to be afraid to use release candidates. But yeah, it's too late now. Last year in June, we then had the first release candidate for 1.1. And it only took us 1 month to get to the final 1.1 release. So since then, we did 28 patch releases. You are here at the red dot now, and hopefully soon you'll get a 1.2, but more on that later. So 3 years ago at ElixirConf EU, Chris showed this slide on ideas for features beyond 1.0. And I want to highlight one element in particular, which is Colocated JavaScript hooks, which we actually shipped in 1.1. I will talk about the other ones later, but yeah. So, collocated hooks, right? The idea is that whenever you find yourself needing to write some small amount of JavaScript in your component, instead of like needing to go to the assets folder, like write the hook, think about a global name for the hook, and then maybe have a conflict with the name, you just write it right there next to the code that uses it. So, as an example, it could look like this. You see we have a script tag with a special colon type attribute. And the magic is that we just extract that at compile time. It will land in a special folder. So your bundler, like ESBuild, will pick that up. It will be handled just like any other script you would write and import. So there are no problems with like content security policies. It's just like you define it in a hooks folder and import it yourself. So we needed to come up with a special folder structure to do that, so we can reliably detect like if things are outdated. If you remove a hook from a component, we need to remove that from the file system. So it took a bit until we arrived at that specific structure. The details don't really matter, but yeah, this ensures that files are always up to date. And then finally, you just import from a special Phoenix collocated folder. There's some setup involved for ESBuild, but since Phoenix 1.8, like new projects include that configuration. And of course, it's also part of the changelog and the documentation. Behind the scenes of collocated hooks, we actually have something that we call macro components. So you might ask, instead of like collocated hook, could there be also like something else? And yes, there could be. But right now, the actual macro component behavior is still a private API. The idea is that you get an AST representation of your template, and you can potentially transform that and return that AST. And for a collocated hook, we just like return an empty string, which says it, remove that part from the template. The reason it's still private is that the initial implementation for macro components and the AST was quite limited, and we didn't want to ship that. And since that, it evolved a bit, but like we still didn't want to commit to a specific public HEEX AST format yet. Like I still want to have that at some point, and if you are brave, you can write macro components today. You just need to be aware that there may be breaking changes, so it's not documented. But there is some documentation in the code itself if you want to have a look. The other big feature we added in LiveView 1.1 is what we call keyed comprehensions. So here is a quote from the LiveView 1.0 docs that basically says whenever you render a comprehension and you change the assign for your comprehension, you need to be aware that all elements of that comprehension will be resent over the wire. Like when you append an item to a list, it will send all entries of that list. So here's an example. You could have that very simple template rendering a list of items, and on the right you can see the actual div that we would send. It is still optimized to not send the static parts of the template, but still, if you have a like 2-element list, you add a third item, you would get first, second, and third. Of course, we already had a solution if that's a problem, so you could use a stream instead. Like, you could write stream insert, same example, you have 2 elements, add the third one with stream insert, and you'd get the div on the right. So only the third item and like a bit of bookkeeping for the stream itself. Streams aren't always the perfect solution. Like, you have to do like bookkeeping yourself to know what's actually rendered. So you may not want to use them for all cases. You could also have used live components in the past already, because those are change tracked separately. But using them for this example is a bit inconvenient. Like, you need to define a whole separate module just for that list item. But when you look at the div is actually quite good. Like, we only send the third item. Again, example, 2 elements, you add another one. And we also send like the list of component IDs. So, back to what we actually want. Like, we want to write what's on the left, and the div for 1.0 would look like what you see on the right. Now, for keyed comprehensions, it's only slightly different. Like, we have a new K key, and we send like the total amount of items, so we can properly prune things. If you remove something from a list, like the front end needs to know, oh, there are now less items, so we can remove those. But this is how the div for a keyed comprehension will look like, or looks like. So it is called keyed comprehensions for a reason, right? So if you have some stable identifier for the items you render, you can provide a :key attribute, and LiveView will use that to optimize the div. When you append something to the very end of a list, it doesn't really matter, but whenever you move items around, the key actually helps a lot. Like, if we have the same example, you have 2 items. Now, instead of appending something at the end, we inject one in the middle. We would just say, okay, the element at index 1 is the new item. The element at index 2 is the one that was at index 1 previously, so the front end just moves those around, and we have still like 3 items in total. So those are keyed comprehensions. Now, back to Chris. We have collocated hooks. We also have keyed comprehensions. But what about the other features he mentioned? So the first one, the dev debugger, it was about like improving the situation where you develop a live view and it crashes, for example. You did something wrong. You just get an error flash. It reconnects, and you need to look at the logs, right, to see what happened. The idea was to maybe have something like the plug debugger page where we show the actual error message. Maybe you click next to reconnect. And we still don't have that feature, but there's a very nice project from Software Mansion. Big shout out there. It's called Live Debugger, which gives you very nice insights into what's going on in your live views. It can also show you what happens when a live view crashed. So I'd say we can give that one a check mark, and maybe we still revisit it in the future, but I think this one is pretty nice. So the other feature that was mentioned was about unified messaging. So back then you couldn't pass the myself assign to send update, so it was very inconvenient if you want to message the parent. I think what you also couldn't do, but I'm not sure about, is actually like define an attribute as a function. You can do that for a function component, so right now we usually say just pass like a function to your component, and then it can message the parent. Like, it's not perfect, it's still different for a live view and a live component, but I'll say for now it's fine. Maybe we revisit it at some point, but I'll give it a check mark. So the last feature that was mentioned was a live session stash. The idea is that because we already have the WebSocket connection, right, it is long-lived, why do you need to refetch something from the database every time you navigate between LiveView pages? Couldn't there be a way to share data? And There is a draft PR for something like that, but it is more complicated than you might think. So the PR only handles one case, which is the case where the client initiates the navigation. But of course, you can also navigate from the server, like with push navigate. And to properly do that, we need to do some changes to like channels itself. So sadly, no check mark on this one, but I still want to solve it at some point. But no ETA. Now, let's actually talk about LiveView 1.2. So we talked about what happened so far, and LiveView 1.2 compared to 1.1 is going to be a smaller release. We have a couple of quality of life improvements. For example, in LiveView 1.0, we changed how unused fields and forms are tracked. So since then, every input that wasn't touched will send a separate unused field over the wire. Sometimes you might not want that. You can now opt out of that per field with a new attribute. Very small thing, but we also added a way to encode JS structs. So if you do something like a js.show, you can now send those over push event. So previously, you would have to encode them into some attribute in your template, then refer back to that attribute in like livesocket.exec.js. Now you can just push event those. It will be encoded. If you use like JSON or JSON, or like if you use something else like Poison, you can just call js.toEncodable to encode it. Also a very small feature. What is pretty nice is we now have a behavior to format script and style tags in your Heeks templates, which is especially useful for collocated hooks. You can define a behavior and, for example, call something like prettier. We actually use that in the LiveView repository because we use prettier to format all the JavaScript code we have for LiveView. But yeah, you can check the documentation for details. It's just implement this one callback, usually like invoke npx prettier, something like that, and we will format. Finally, a big feature in LiveView 1.2 will be Colocated CSS with optional scoping. And the idea for that is basically the same as with collocated hooks, right? So you can write your template, include a style tag, write your CSS, and it will be extracted at compile time. Whatever tool you use, like Tailwind or ESBuild, can then pick that up, bundle into your app CSS file, and optionally, you can also scope the styles so that it only affects that very template. Maybe you noticed in the code example that it says myapp.collocated.css. That's because we decided not to ship a specific scoping implementation by default yet. The reason is that there is a new CSS feature with like add scope syntax. Nowadays, it's pretty new though. So for example, in Firefox, there are still some problems, especially when morph DOM changes the DOM and styles don't apply. So we have an example to do the scoping in the documentation, but we didn't want to ship that when it's like doesn't feel quite ready yet. Now, when we implemented Colocated CSS, we actually found a bit of a challenge because of the way how we compile the Heeks templates. Heeks is based on EEX, which is just a way to embed Elixir code in text. And Heeks, as a custom EEX engine, works on the text tokens, but still relies on like regular EEX handling for expressions. So in this example, this is how EEX looks like. You're probably all familiar with that. And if we look at an example, like template, what would happen if you define some kind of nesting, like an if expression in your template, is that we'd compile any nesting first, basically inside out. So we'd tokenize the start, the div, the nesting starts. We handle the if expression, the nesting ends. Like first we handled the text inside, of course, but at that point, we basically compile that to the final change tracking code, and then we continue with the rest of the template. And the problem for that is that basically we don't have a point where we have the full template and can look at all what's inside. So we only process the outermost part at the very end, which is kind of too late for Colocated CSS because we need to inject some custom attribute in most cases. So what we actually did is we split the template compilation into multiple steps. So we first tokenize and parse, and then we have a separate compilation step, which also solved the problem that we had some duplication with the Heeks formatter, like the HTML formatter you use. And we could then share that code. And yeah, it's a nice thing that simplifies the LiveView code. So yeah, it was a bigger change than I initially anticipated when the PR for Colocated CSS came up. I want to shout out David Green. I'm not sure if they're here, but basically sent the PR, kickstarted the whole effort, and also gave a lot of feedback on the subsequent pull requests. I also want to shout out all the other contributors that we had for LiveView and Phoenix. Those are just stats from GitHub in the last 12 months. So yeah, thank you very much. We will have a 1.2.0 release candidate published later today. With the changes to the Heeks compilation in mind, I want to say please try it out, report if there are any issues. And yeah, that is all I have time for. I want to thank Dashbit for allowing me to work on open source. And I want to thank all of you. I actually included the QR code in the slides. So if you have feedback, please write in the app, or I don't know if we have time for questions now, maybe, maybe not, or just come to me after the talk. Thank you. Yes.
All right, we got time for about one question. So I got a good one online at SwapCard. All right, from Gabriel. When doing complex, pure front-end interactions, writing JavaScript code in the hooks gets messy. Is there any way to have the templates that can be evaluated just with state in the front end, like you were integrating Alpine JS or something similar, but integrated into LiveView?
I mean, yeah, hooks can get complicated fast, and sometimes you want to have like the pure client-side interaction. I think the best you can do is probably write a web component. Like if you say purely client-side, you don't need to interact with anything from the LiveView. Maybe with events, try a web component. I did an experiment that basically says like a mixture where LiveView can still patch stuff, but we will keep track of attributes on the client. There is a pull request for that, which helps in some cases, for example, with the Tailwind Elements library. Like it tries to change attributes on the client and it will mess with LiveView. But yeah, I'm not sure if that would fully help in that case, but it still allows some kind of interaction. Again, if you need no interaction with the server, you just want client-side stuff, try web components. I think that's the best bet right now, at least.
All right, thank you, Steffen. One more round of applause for Steffen.